I warmly welcome you to the presentation about the paper called Quantification of Knowledge Transfers, the design of an experiment setting for the examination of knowledge transfers. In this session, I'm going to speak about the DFG-funded research project in which we realize labor studies to research knowledge transfers quantitatively. This means we are attempting to create a quantitative model about knowledge transfers. With this model, we intend to analyze knowledge-intensive processes, generate an expectation about their outcomes, and derive measures for process improvement. The agenda for this presentation can be seen here. First, I would like to motivate for our research. Then, the underlying research method is issued. The new artifact designed is presented thereafter. As we are already realizing experiments based on this, some insights are given about our experiences. So far, the paper speaks about a theoretical validation only. This will be issued in the next session. Hence, I would like to exemplify how we vary influence factors in the experiment realization. Limitations and further research needs are presented then. Aside the theoretical grounding of our research and its research gap, which you can find in the paper of course, we have realized a workshop session at the conference called WI 2020. This conference is the biggest conference of business informatics in Germany, and we have focused on the most important next steps for knowledge management. Originally, we wanted to work out a research agenda and discuss relevant agenda items. However, we have identified current steps that all lead to the construction of one joint transfer model. Hence, we have posed the following research question. How can quantitative effects of influence factors on knowledge transfers be examined by an experiment so that a joint transfer model can be constructed? Particularly, qualitative-based aspects have been very prominent at the agenda. We wanted to consider this in our research too. If we had such a model, we could, for instance, generate statements about the expected quality of knowledge transfer outcomes. Hopefully, we even could control transfers so that the quality will increase. Some initial assumptions we came up with are the following. First, the more competent I am, the higher the quality achieved in conversions. Second, the more complex a task is, the smaller the quality of its solution will be. Of course, we are speaking about time-limited situations. Third, the more sticky knowledge is that needs to be used at a task solution, the worse the quality will be. Fourth, there is a certain point of time pressure which is optimal for the quality achieved. Less time pressure decreases the quality, more time pressure decreases the quality too. But what is a knowledge transfer exactly? At the CIRC conference, we have discussed the following model. We are speaking about a kind of sequence in which 1. Knowledge needs to be identified at a certain knowledge source. 2. It needs to be transferred. And 3. It needs to be applied at the knowledge receiver. As an example, imagine reading a book. The book represents the knowledge source. Through the activity of reading, knowledge is transferred to a person. New knowledge is applied at mental models of that person. Along the sequence, different influence factors and different kinds of knowledge objects are involved, which all need to be considered by the experiment. Considering all kinds of knowledge transfers, the experiment has to consider the conversions highlighted in green. These are based on the 3 different kinds of knowledge forms being a source and the same 3 different kinds of knowledge forms being a target. Hence, the experiment needs to guarantee their individual observation. You see, we have to consider certain requirements for the construction of an appropriate experiment setting. Hence, let's face a methodology which will be helpful for this. From our perspective, that's the Design Science Research Methodology from Peffers et al. Here, objectives, or rather requirements for a solution, are specified before the artifact is designed. In our case, the artifact refers to an experiment which is capable to gather data required for the construction of a quantitative knowledge transfer model. This artifact will be demonstrated in laboratory studies and then evaluated. Finally, results are communicated. Requirements we came up with are the following. First, we need to consider relevant forms of knowledge. You can see them here. Second, we need to control effects of interrelating activities, like this shape shows. Third, we need to measure influence factors and enable the observations of their effects through variations. As an example, you can imagine to raise the competence C, reduce the stickiness S, increase time pressure P, or change tasks complexity K. At least these three are the relevant requirements I would like to focus on at this presentation. So how does the design of an experiment finally look like? Our design is based on the following three kinds of components. First, the modeling of knowledge-intensive tasks. Each experiment process focuses on a certain kind of knowledge transfer and knowledge-intensive tasks required. It perfectly controls who does what at a certain time point in the experiment process and what for information is provided. Second, the modeling of an overview process that issues how individual task sequences are integrated, how experiment variations are realized, and how tasks are decoupled from each other. Third, the modeling of activity views that issue the precise time measurement. They show knowledge occurrence and they manage the perfect controlling in the experiment process. Let's have a look on some examples. Let's focus on the internalization experiment process. So as a knowledge source, an exemplary video will be presented. You can see it at the very left bottom of the model. In our case, this video explains how to construct process models on behalf of a new kind of modeling language. The instruction introduces the task of internalization, which is part of the experiment. Here, relevant knowledge is transferred to the knowledge recipient and applied at its mental knowledge base. In the next task, the recipient is asked to construct a process model. By this control task, it can be confirmed that relevant knowledge successfully has been transferred to the recipient's head. The first insight is that these two kinds of tasks need to be isolated. So, the time measurement only needs to be realized at the first task. Hence, it has received a thick shape border. The experience of the knowledge recipient about the knowledge transfer will be served as a third task, which is called characterized transfer. A survey grid will be used for the structured data gathering. As an outcome, the knowledge understanding is documented and ready for analysis. Finally, after all internalization experiments have been realized, the test person's outcome can be evaluated. In our case, this refers to the evaluation of the quality of process models constructed. At which part of the process knowledge is generated, which kind of knowledge is generated, and how activities are separated All this can be specified by the activity view. So the task of internalization can be isolated by design from the knowledge control task. Further, one can specify the part of the process that is affected by the initially selected influence factors of stickiness S, pressure of time P, the task's complexity K, and competence C. Let's have a look on a more sophisticated second example. Let's focus on the socialization experiment in which a team of 2 test persons is involved. Their interaction has been specified with the aid of the process model presented here. In principle, we can see the same tasks than presented before. There's an internalization task which is carried out by the knowledge source. We can see the control task which is realized by the knowledge recipient. We have the characterized transfer task that is realized by both the knowledge source and the knowledge recipient. The evaluation task is performed after the experiment by the scientist. Right in the center of the model, we have the relevant socialization task. Here, the knowledge source explains how to construct process models by the novel process modeling language that has been presented in the video before. Through the activity of communicating, the knowledge recipient is equipped by relevant knowledge, which will be required to carry out the control task. The corresponding knowledge generation can be visualized by the activity view. Right in the gray-colored center, the time measurement needs to be carried out. Further, here we see only purple-colored tacit knowledge objects. Because we issue this socialization, we can recognize the clean isolation of this relevant activity and successful decoupling of further activities by the avoidance of different kinds of knowledge objects. Further, we recognize competence levels at both kinds of test persons, the knowledge source and the knowledge receiver. We need to consider this at the team building of socialization experiments. Please remark, more details about the other kinds of knowledge transfers can be found at the paper. Hence, I would prefer looking at the overview process because here the experiment realization is managed. Looking at the joint experiment process, you can find the individual 5 kinds of experiment parts right in the center. We have only had a look on one at the presentation so far. The concrete part that will be realized at the experiment will be randomized for every participant. Further, we see the experiment preparation can be realized before the day of the experiment. For instance, so a teaming of competent groups can be created. This is required because we need to control participant competence. Hence, for team experiments, in-place experiments are attractive. Further, we see single experiments can be realized in one fly by anonymous participants. Hence, online experiments are attractive for single experiments. The performance evaluation and the data analysis can be realized on separate days. So much about the design of the artifact of the experiment design. Let's bring it to demonstration phase. We are already realizing experiment based on the design presented. Particularly because of COVID-19, the experiment realization was challenging. This is not presented at the paper, but we think it is interesting to talk about. Just to mention some points. We had to come up with an experiment integration with a video conference solution because the team experiment asked for participant communication. Further, we had to come up with a collaborative modeling environment with which we collect process models created immediately and remotely. Finally, we realized on-site remote experiments with anonymized students we could arrange in competent teams. Further, we realized anonymous online experiments. Finally, we managed, and now we are looking forward to data analysis. For the experiment realization, based on the experiment design presented, we further had to develop the following. A new modeling language, 5 individual tutorial texts for sticky and non-sticky experiment settings, 5 individual tutorial videos for sticky and non-sticky experiment settings, 5 individual modeling tasks, German and English experiment variants, because mother tongue was to be considered relevant. We have realized a pretest and we have considered feedback given by test persons. The final time configuration of the experiment has been based on the time required by test persons of the pretest. Since we know how long the one or other test person has needed to carry out a certain task, we were able to specify time pressure by providing more or less time. In the sense of a validation, we can test on the variation of influence factors. So let's focus on the internalization again. The complexity of the explanatory video can be increased by considering more modeling items and more item connections at the modeling language explained. The stickiness can be raised by removing item names from the video. Hence, it is more difficult to recognize and understand the new modeling language. The time pressure can be increased by providing less time for a relevant task. Of course, remaining time needs to be displayed at the experiment. The competence can be controlled by surveying the participants' competence fields. After the survey, groups for competent and less competent participants can be created. Let's have a look on the socialization experiment again. The stickiness S, the task complexity K, and the time pressure P can be varied on the same way than presented before. Only the competence C needs to be varied differently. As we have two kinds of test persons, we have to vary the competence of both, the knowledge source and the knowledge recipient. Assuming to have only two levels of competences, which are competent and more competent, the experiment will take 4 kinds of teams. First, teams that have only competent members. Second, teams that have only more competent members. Third, teams with a competent knowledge source and a more competent knowledge receiver. Fourth, teams with a competent knowledge receiver and a more competent knowledge source. Let's face the conclusion. Although we are already realizing these experiments, in the paper we only can speak about a theoretical validation and a pretest. We focus on only one experiment task, which is the creation of process models. Hence, on-building research should expand experiment tasks and consider alternatives to the construction of process models. As a next step in our research, current experiment data needs to be analyzed by statistical instruments. In our opinion, future research must face the non-isolated, non-laboratory setting so that findings can be transferred to the reality. So we are looking forward to the future research steps, and we thank you for your attention.